welcome to the Small Caps Podcast, where we discuss news and information related to ASX-listed companies and financial markets, keeping investors informed. Note that the content in this podcast is not financial or investment advice, and be sure to head over to smallcaps.com.au to get the latest market news. Now, without further delay, here's today's podcast.
Welcome back to Small Caps. My name's Kerry Stevenson, and today we're going to be talking about taking big things and making them a little bit smaller in the medical device sector, I guess. Joining me today is Executive Director and co-founder of mVision, Scott Kirkland. Scott, welcome to Small Caps. Great to see you. Can't wait to dive into this because it's pretty interesting what you guys are doing.
It's a pleasure to be here, Kerry. Thank you for having me.
Well, let's start off very quickly with who are mVision and what problem is it that you're trying to, or you are solving?
Sure. So our aim is really to address accessibility challenges in imaging. We were set up in 2017. We acquired a portfolio of IP out of the University of Queensland, which is really around a unique way to image the human body, known as electromagnetic microwave imaging.
Right. It's
not X-ray, it's not CT, it's not MRI, it's not ultrasound. It's an entirely novel way to look inside the human body and create high-quality images.
Oh, so it's not MRI or CT. This is a completely new way of imaging the body.
Correct. So it uses EM waves in the microwave spectrum, about 500 megahertz to 2 gigahertz, and probably a comparable scanner in many ways would be a millimeter wave scanner in the airport. You know, when you walk into those, it's been a while since most of us have been in the airport, but your arms up and they send microwave signals into your clothes looking for hidden objects, metallic objects and the like. And we go through those all the time. They're very safe. They're at a high frequency. They're about 10 gigahertz plus, but the underlying principles are similar. So if you use different antennas, different algorithms, different switching network, you can actually send those signals into the body and then recreate images of internal organs. So EM microwave, it is safe. There's no ionizing radiation. So that is one of the challenges with X-rays. There's ionizing radiation, requires a radiographer to operate it, a lot of shielding typically. But what that means for us is continuous monitoring is an opportunity in the future. You know, not just to scan once every 24, 48 hours, but as necessary every 30 minutes, every 2 hours, etc.
Is there an issue if you take, for example, in the traditional X-ray and all that sort of stuff, is there an issue if you want to continually X-ray people? Is that a problem?
It can increase your risk of cancer down the track. Okay. For something like stroke, which we'll talk about, because it's such a medical emergency, that's a low consideration. You know, the important thing is getting that image completed as quickly as possible. But when it comes to repeated scans, yes, it can certainly increase your risks.
Okay, well, by the way, mVision, the ASX code is EMV, ladies and gentlemen. So ASX EMV, forgot to say that at the start because everyone wants to check it out. We're all investors out here. So with mVision, you are focused first and foremost, it's come out of the University of Queensland, and you're focusing on stroke. How big a market is that, and why are you focusing on the stroke market?
Well, there's a few really good reasons. It's a leading cause of disability, a leading cause of death. It's a huge health economic burden. So if you think about the inpatient costs, the outpatient care, prescription medicine, all the in-hospital treatments, rehab, carers, lost time off work, inability to return to work, you know, all these costs add up, and most stroke survivors have some form of permanent disability. So in the US, the cost is around 100 billion a year. In Australia, it's 105 billion a year. Yeah, so whoa, it's big. And in Australia, it's about 5 to 6 is the estimate. What's really important is there are very effective treatments, very powerful treatments. You can do something about it. So, you know, there's no point scanning someone if you can't intervene and improve their condition. So that's why we're focusing on stroke. And part of the value proposition of our technology is its portability, its accessibility. being able to bring it to the patient wherever they are, which is really important for time-sensitive emergencies like stroke. So
now you mentioned before, putting your hands up at the airport. Those things are massive, and heavy. What you're developing, and I want to talk timelines now as well, because we're talking investment here. Are yours lightweight or portable? Let's talk about what it is.
Sure. So our operational clinical prototype is about the size of a mid-range ultrasound unit. So think of an ultrasound unit that sits on a cart, and like ultrasound, can be easily wheeled around in between beds, can even fit in a very crowded area like ICU. So the actual hardware, I'll show you one of the antennas. So you can see it's the ceramic antennas. So compare that to an X-ray tube or magnets in MRI. There's about 16 of these that sit in a headset that sits on the cart. So that's our first gen device. Our second gen device is ultra lightweight, just a headset that sits in an ambulance, and we're paralleling the development of those two devices.
When you say a headset, are you talking about a headset that I put on my head? And I'm just trying to visualize now, because I'm a big visual person.
Sure. You can think of it like a stack helmet, like a bicycle helmet.
Okay. So they pop that on your head, and that gives a good image. And with stroke, you've got to figure out first and foremost, is it a blood clot or is it a bleed? That's pretty important too. So
spot on.
That gives you fast diagnosis.
And today the patient needs to go to the CT, first lab plain CT, angiogram, CT perfusion contrast to answer those questions. So we're looking to bring it to the patient and make that very quick determination. Is it ischemic? Is it hemorrhagic? And pursue the appropriate treatment.
So right now, Scott, if don't want to put that out there, but if one was to have a stroke, ambulance arrives, they can't do very much except you've had a stroke, we'll get you to the hospital. Is that correct? And they've got to wait till they get to the hospital. Whereas what you're saying is down the road, you can have these things in the ambulance and they can do a very quick assessment to give the drugs that are appropriate for whether it's.
That's correct. That is a model that's being pioneered throughout the world. There's about 30 or so sites that are conducting what's called a mobile stroke unit study, where they jam a CT in the back of an ambulance. It's a huge amount of customization. These things are trucks, upgraded suspension, upgraded engines. In Australia, they had to reposition the beds to sit in the center of the ambulance so the patient could be positioned correctly in the CT. Got a radiographer on board, but they are demonstrating that diagnosing and treating the patient in the driveway of their home is the emerging standard of care. So a study that was published out of the US recently, it was called Best MSU. They enrolled about 1,000 stroke patients across 7 sites. They reported an ability to treat 33% of stroke patients in the golden hour for the mobile stroke unit versus just 3% for standard management. So that is a huge difference in being able to minimize patient disability. And there's, sorry,
okay, well, what I want to do is I want to have a listen. I want to understand MVision and where you're at from a commercialization point of view now. Because you listed, I think, in 2017. Is that right?
Late 2018.
Late 2018. So not that long ago.
Yeah.
Are you hitting your milestones? And what's commercialization look like? How's this being used?
Sure. Yeah. I think we've got a very strong record in hitting our milestones and have been rewarded for that. We developed our operational prototype about 1.5 years ago or so, probably a bit longer than that. That's been the subject of a pilot study at the Princess Alexandra Hospital in Brisbane. So this was the first time that technology was used on stroke patients. We wanted to see how do our images correlate with the ground truth, being CT and MRI. And we saw a really nice correlation, both in classification, being able to differentiate the stroke types, but also localize the lesion in the same area as CT and MRI. So we use that data to tune our imaging algorithms and improve the hardware. So 30 patients, we're going to enroll another 20 patients. And in parallel, we're developing our first commercial unit. So this is a unit that isn't a prototype, it's designed for manufacture. We will have the first units fabricated around the middle of this year. and then we'll be taking them into a multi-site clinical study. And that the intention of that study is to generate the data we need for our first regulatory submissions.
Okay.
FDA, TGA, CE, and along that process, we'll be expanding upon our commercial relationships as well.
It takes a while to bring these to market. When coronavirus first hit, your share price was about 50 cents. It's quite strong today, so it's clear that there's a nice progression of and people understanding what you're doing. But there are others that are doing something similar, and I hate to break this up, but hey, Nanox, I think it's listed on the NASDAQ in the US, $1.5 billion company. Is that a threat to you guys, or are you looking at that as, you know what, Kerry, what they're doing is not quite the same as what we're doing?
Yeah, they're in the same space in that they are looking to disrupt medical imaging, but they have a very different approach in that they are pursuing it's more like a routine scan model. So trying to intervene earlier, detect cancers earlier by giving every person on Earth a CT scan every year. Now, it's quite a unique model, and I think from a investor perspective, they're not playing in the same spaces as Envision. You know, it's a routine scan, it's a stationary device.
Right.
We are a much smaller mobile device geared specifically for stroke care. So, but it does highlight the investor appetite for novel approaches to imaging.
We've talked a lot about sort of mobile imaging and in ambulances and stuff, but how will it be used in hospitals?
Yeah, sure. So, and that's where we're starting, and there's a big unmet need. There's two key areas. So the first is emergency departments, whereby particularly smaller and regional hospitals that may not have access to high-end CT, or hospitals where CT is not practical or accessible for whatever reason. The other area is after initial treatment and monitoring the effect of that treatment and complications. So I think I talked before about the very effective treatments, thrombolysis, thrombectomy. So thrombolysis, drugs to dissolve a clot, thrombectomy, physically retrieving the clot. They can have complications. So what's known as hemorrhagic transformation or secondary bleeding. Around 6% of stroke patients that get the thrombolysis will go on to have a secondary bleed. It's around 10% that have clot retrieval have a bleed, and a bleed can be catastrophic. So today, there's no way to monitor that by the bedside, whether that patient's in ICU, the stroke ward, neurology. Is that patient getting sleepy? It's physical observation. And sometimes the clinical symptoms can lag the actual expansion of a bleed. So being able to monitor that closely and intervene earlier is a completely new area for stroke care, and certainly one that, we work with neurologists, radiologists, critical care. They're all very interested in that space, as well as the pre-hospital upfront diagnosis. So that's where we're starting in the hospital environment. We're using the data from our studies in there to also support our ambulance model as well.
In terms of cost, because you talked regional hospitals as well, and the cost is an issue. Sounds to me like technology is playing quite a big part in Envision's vision. Is there a big cost factor for hospitals in purchasing these units?
Yeah, absolutely. There's a lot of CapEx pressures around the world, and to sell a lot of units, you need to offer a very flexible model. And so we're looking at two different models, both a more traditional capital equipment, consumables, accessories, maintenance, and then a monthly subscription model whereby, delivery of the unit, training, all the accessories, all the upgrades is all bundled in at a monthly, which is, if there's pressures on upfront CapEx purchases, that could be more attractive. From a retail pricing perspective, we're looking to price the device around the mid ultrasound range, so between 100 and 150,000 US, which, can be around the cost of a maintenance of an MRI each year. So,
wow.
Yeah, it's certainly a fraction of the cost of mainstays, and has a very strong value proposition in stroke care.
just want to be really clear, is your unit and this technology, does it do away with those massive CT, MRI heavy machinery? Does yours cover all that? It doesn't, does it?
No. So it complements those. And our value proposition is really about providing good quality images. We're not trying to provide MRI images, but good quality images that a clinician can use to make a treatment decision or a triage decision at the point of care. So where CT and MRI are not practical or accessible.
Okay, so it's that critical point, as you say, and with strokes, that's even more important.
Correct.
Now, Scott, I have to ask this, skin in the game, because I often say to all of you out there, don't I, have to go to look at management, look at where they've come from, look at what they're doing. But why should people invest now? And do you as directors, have you got skin in the game?
Yeah,
hope you don't mind me asking that one.
It's a very good question, and yes, all the directors, executives, myself, and Ron, our CEO, we're all top 10 shareholders. Plenty of skin in the game. Purchased more shares since listing. Ron purchased some on market very recently, just a week ago or so. So we've all got plenty of skin in the game, and I think we know it's a very big addressable market for stroke care. We know clinicians want this device, neurologists, radiologists want this device. Stroke is the starting point for us. It really is a platform, and beyond stroke, using the same hardware, we can target other indications like traumatic brain injury, and then brain tumors, etc. And then that's, looking at the rest of the body, there's plenty of opportunity there. So, Ron likes to talk about the notion of investing in M-Vision is a little bit like investing in CT in the 70s or MRI in the 80s. It's not just a portable brain scanner for stroke. There is a pipeline of opportunities that will come through in time.
So if you were sitting talking to investors like you are right now, why do you think now is a good time to be looking at M-Vision and putting some of our hard-earned cash towards a vision that, revenue's not going to be immediate. So why is now such a good time? Sure.
Well, we've got plenty of big catalysts coming up. So I talked about the fabrication of our commercial units, taking those into big expanded multi-center studies. We're enrolling another 20 patients at the PA, so there'll be more clinical data to report on. We're in the late stages of an FDA breakthrough status application. And we've also talked previously about expanding upon our commercial collaboration. So there's plenty to look forward to this year.
Just my final question would be, obviously it's an ASX listed company. You're focusing here in Australia at the moment, but is the other markets like Europe, the US, are they interested in what you're doing, or are you keeping a little bit under the radar at the moment?
No, look, we're certainly building the device for not just the Australian market, but the US market is a very big focus of ours. I think it's interesting. Historically, Australian medical devices, from a regulatory perspective, have pursued CE mark first, which is clearance to sell into Europe. But from a practical perspective, they will generally get more traction in the US. So selling into France, the healthcare system in France is different from North Germany, from South Germany, from Spain. Yeah. They all have their unique intricacies. So from a regulatory perspective, we're really focused on FDA, TGA, and then CE mark, but from a commercial perspective, really about getting into the States, as well as generating reference sites in Australia.
Plenty of news flow coming out of M-Vision for the future. I wish you all the best. It's been great chatting to you today. And it's wonderful to know that you are doing transformative point of care imaging. I wish you all the best. Thanks for talking.
Thanks, Gary. Appreciate it. Thank you.